The following lever is used to lift a crate of 2,100 newtons. If the crate is 0.75 meters from the fulcrum and the worker pushes 2.25 meters from the fulcrum, what is the mechanical advantage of the lever? Now I'm given a lot of information here. First off, I am given a force out. I'm given a force out. That's how much the crate masses. But then I'm also given a displacement out because it tells me that from the fulcrum to where the crate is 0.75 meters. I'm also given a displacement in, and that is 2.25 meters. And now it simply becomes a question of which mechanical advantage do I use? And if I see that, listen, I have displacements, I'm going to use ideal in order to figure it out. And mechanical advantage ideal deals with distances or displacements, and I have two distances. And so that is displacement in over displacement out. And so I am going to, my displacement in is 2.25, and I'm going to divide that by 0.75. Now, when I do the math, when I simply take 2.25 and divide by 0.75, I get a response of 3. But I need to write that as 3 to 1 or 3 to 1. Well, how much force is needed to lift up the crate? Well, once again, I have a force out of 2,100 newtons. But now, from the first problem, I know that our mechanical advantage is 3 to 1. The thing that I'm looking for is force in, and that's going to be in newtons. And if that is the case, mechanical advantage real equals force out over force in. So, if I substitute numbers for letters, I know that 2,100 newtons divided by force in, but that whole thing needs to be equal to 3 to 1. So if I cross multiply, I get 3 force in equals 2,100, and so I get force in equals, I divide 3 by both sides, 700 newtons.